Hello and welcome back to the lesson 9 of the tutorial series simulating your custom robotic arm in ROS Noetic. In our previous tutorial, we had created the arm_urdf.launch file to load our URDF file and the joint trajectory controllers of our robotic arm. In this tutorial, we will create a new package which will be the Moveit Manipulator Package, which will be used to simulate or move our robotic arm in Gazebo and Rviz. So for that, we are going to use Moveit Setup Assistant. But before that, if you have not watched my previous tutorial in which we launched our robotic arm in Gazebo, you can watch that from here. Now I will close the simulation running in my terminal. So I will close all the file by pressing Control C by going into that terminal. Also, I will stop the ROS master running in the another terminal. So I have closed the ROS master and I have closed the Gazebo simulation that was running. Now open the PDF file. I will give the link to this PDF file in the video description. So before we start creating our Moveit Manipulator package, we need to install the Moveit for the ROS Noetic and the ROS controllers, which are used to control our robotic arm. So you may have already installed it, but make sure to run this command in your terminal. So first thing you need to do is type the command sudo apt-get update and press enter. Give your Ubuntu password so that it will update all the Ubuntu packages. Now copy this command and paste it here. So this command will only work for ROS Noetic. If your ROS version is different, you need to replace the ROS distro from here. Now press enter. So if you have not already installed it, it will install the package, or if there is anything updated, it will update from there. Now next copy the command to install the ROS controllers and paste it here and press the enter command. Now we have successfully installed all the tools necessary. Now type the command clear to clear the terminal. Now to create the Moveit package, we need to go to our Moveit workspace or Catkin workspace. But here are some points that you need to remember. So while creating the manipulator package, in the steps when we create the predefined positions, you may face some issues with like your joints may move in a wrong direction. So if you face this issue, you can use this link for the tutorial that I have created for the ROS Melodic, where I have explained all the steps to solve those wrong direction movement issues for the robotic joints. In this tutorial, I will not explain those steps because my URDF file that I have provided is correct. So let's go to next step. The first thing is you need to go to your Moveit workspace. You need to build your Catkin workspace, and then we will source the devel/setup.bash file, and then we will launch the Moveit Setup Assistant. So please follow me. So first we will go to the our Moveit or Catkin workspace. So type the command cd space the move home symbol, the tilde and forward slash, and then move it under your Catkin workspace name slash and press enter. Now type the command catkin build and press enter. Then type the command source devel slash setup dot bash and press enter. Now again type the command clear to clear the terminal. Now we need to open the Moveit Setup Assistant. So type the command ROS launch. Again, make sure you source the setup.bash file of your Catkin workspace before launching the Moveit Setup Assistant. Otherwise, you will get some errors while creating the package. So for your confirmation, I will again source the devel/setup.bash file and now run the command ROS launch Moveit Setup Assistant and then type setup assistant dot launch and press enter. So it will open the Moveit Setup Assistant. So I will maximize the window now. Now click on create new Moveit configuration package. Here click on this browse button and go to your home directory, your Catkin workspace, the SRC folder, your robotic arm package, its URDF folder, and select the URDF file from there and click on open and then click on load files. So here one thing you need to note down is when you load this file, your preview should be look like this, or whatever your CAD model is there, it should look properly. If you see the links like they are not properly connected or they are scattered everywhere, then there is something wrong with your URDF file. You need to check the URDF file and remove the errors and then again check until this CAD model loads very intact. So my CAD model is perfectly loaded. So I will proceed with the next step. I will position it little bit like this, because in next steps we are going to create some predefined poses, so this view will be good. Now go to self collisions. This sampling density set to high and click on generate collision matrix. So it will create a relation like which links will never collide with each other. If you select on any of these links, it will show you the relation that it has created. So you don't need to do anything here. Directly go to the virtual joints. Here you don't need to do anything. Next, go to the planning groups. Now here we need to divide our robotic arm links into different groups. So first we are going to divide our robotic arm links into one group and the end effector links into one group. So go to the add group command. Now for the arm group, for the arm links, I will give the name r underscore group, arm underscore group. Then the kinematic solver, because we are going to use inverse kinematics for our robotic arm, I will select the KDL kinematics plugin. Next, the other values you need to keep as it is, and in the OMPL planning you need to select RRT. It is the by default one. Select RRT. Next, click on add joints. Now for my robotic arm, the joint 1 to joint 5 are of my robotic arm. So what I will do is I will click on joint 1 and then I will keep the shift key on my keyboard pressed, and then I will select joint 5. So it will select all the joints from joint 1 to joint 5 and then click on this right facing arrow. So it will add this joint into my arm group. Click on save. Similarly, we need to add another group for our end effector. So click on add group, give the name. So I will give it a name as hand, or you can give name as hand group, but I will give it a name as hand. And you don't need to select any kinematic solver or OMPL planner then, because it is a simple links. So then go to add joints and select the joint 6 and joint 7 and click on the right facing arrow. Now save the group. So here you can see we have created two groups, arm group and hand group. So you can see the joint 1 to 5 are revolute joints and joint 6 to 7 are prismatic joints. Next, we need to add some predefined positions or the by default positions for our various groups. So we will add some positions for our robotic arm as well as the end effector. So click on add position. Now we will first add the positions for the hand. So select the hand. So if you see here, right now our gripper is closed. So I will name the position as hand underscore closed, and I will keep the positions as it is and I will click on save. So we have added one position. Again click on add pose and I will name it as hand opened, and I will move this slider to their opposite direction. Like the joint 6, I will take it to the full, and joint 7, I will take it to its minimum. Like this one I will take to 0.03, and this will I will take to minus 0.3. Now save. Now to add the positions for our arm group, I will situate or position the robot like this. Now click on add pose and select the planning group as arm group. Right now all the links are at their 0 position. So I will name this pose as 0 underscore pose, and I will save that. Again I will click on add pose. Planning group I will select as arm group. Now this pose I will name it as straight up. Please check the spelling mistakes. Now we will move all the joints to their 90-degree position so that our robotic arm will stand up in a vertical position. So for joint 1, if you see, now again before you proceed in this step, make sure all your robotic arm joints are working correctly. So what I will do is I will move the sliders and I will check if all the joints are moving correctly. So if you see, my base joint is moving from 0 to 360-degree. So here the values you see are in radian. So 6.284 means 360-degree. Again, if I check joint 2, it is also moving from the incorrect directions. Again, I will take it to 0. Again, I will check the joint 3. So if you see, the joint 3 is also moving correctly. So I will again take it to 0. Again, go to joint 4 and check if it is moving correctly. And last one is the joint 5. If your joints are moving incorrectly, there is some error in the joint limits of that joint. You need to go to your URDF and you need to change or modify those joint definitions. If you want more help, please watch this video for the details. Now to add the straight position, I will take this joint 2 to the, so okay, this joint 2, I will keep it as 0. For joint 3, I will give the position as minus 1.572, so it will stand straight up. Then for joint 5, again I will give the position as minus 1.572, so it will be also straight up. Now I will save the joint position. Now again click on add pose. Now we will situate or position our robotic arm in a position like that. It will behave just like it is picking an object. So I will name it as like pick object, and I will take the joint 5 to 90 degree. So I will give here 1.572, so it will be at 90 degree. And now I will manually adjust the joints so that it will act just like whether it is lifting an object. So you can do it manually, or you can directly, like at the end, you can directly copy the values that I have shown, or that will be there. Okay, this is good enough. So I will save. You can note down these values and enter in your setup like this and save it. Now again I will click on add position, and I will make it little bit like it is lifting an object up. So I will again take this joint little bit of upward. This one also little, this one I will keep as it is. This one I will make it little like this, and I will name it as lift underscore object, and I will save. Next I will click on add pose, and we will move our robot to the opposite direction, like 3.142, so it will be 80 degree in opposite direction. So I will name it as opposite pose and save it. Again, I will click on add pose. Now I will descend the, I will keep it as it is 3.142, and okay, now I will make the other joints in such a position that it will place the object on the opposite side. Lift it little bit upward. And now name it as drop underscore object and save it. So I think we have added sufficient predefined positions. We can anyway later on program it to go to any positions using the Python script, but these are some predefined positions so that we can test the generated package in Rviz before writing any Python script. Now go to end effectors. Now we need to define the end effector links. So go to add end effector. In end effector name, give it some name. So I will give it name as hand underscore end effector. Here you need to select end effector group. So select the end effector group as hand. The parent link you need to select. So my parent link for the end effector is link 5. The parent group you can keep it empty and click on save. Now we have added our end effector. You don't need to add any passive joints unless and until if you have any joint which is not moving or which is stationary. But in my case, all the joints are movable. Now go to controllers. Here you can add any controller for controlling the trajectory, which will be following the joint trajectory controller that we had created for our robotic arm package. But I will prefer to write the controllers manually to avoid any issue. You can go to simulation and you can copy this URDF file if needed, but I will not do this. I will use my original URDF only. Again, in 3D perception, you don't need to do anything. Directly go to author information and here give your name and give your email address. You can give anything, but I will not enter. You can add your personal email address or whoever is the author, his email address you can add here. If you don't add any author information, Moveit will not allow you to generate the package. So please add the info. Now go to configuration files. Now we need to select the location where you want to generate your manipulation package. So I will go to browse and I will go to home, my Catkin workspace and its SRC folder and click on open. Now it will add the SRC folder here. Now we need to give the name of the package that we want to generate. So add slash and then add the name of the package that you want to generate. So I will name it as Moveit underscore robot underscore arm underscore sim. Now before clicking on the generate package, make sure you have entered the package name and the path correctly, because otherwise if you make any wrong spelling mistake, it will be difficult for you to follow my next tutorials, as in every file you need to make the changes. So please make sure the name is given properly. So I can see it is named properly. Now I will click on generate package. So here it will say like no virtual joints have been added. I will click on OK because mine one don't have any virtual joints. Now if you see, it has successfully generated the Moveit package. So to close the Moveit Setup Assistant, I will open the terminal and here I will press Ctrl C. Now I will close the terminal. Now if I go to my Moveit or Catkin workspace, I can see the package is created here successfully. So if you open that, you will find here two folders are created like config and launch. The cmakelist.txt and package.xml files are also there. So these files you don't need to modify because it contains all the necessary information. If you open the launch folder, here you will find various files are created And here you will find the demo underscore gazebo.launch file, which you can use to load the gazebo simulation for now. So let's test this gazebo demo underscore gazebo.launch file, like how it works. So go to the terminal, type the command ROS core to initialize our ROS master. Again, open a new terminal, go to your Catkin workspace. So my is Moveit underscore WS, and press enter. Type the command source devel slash setup.bash. As we have created this new package, we need to build our Catkin workspace. So type the command catkin build and press enter. So it will build your package and it will tell you if there are any errors. But you can see for me all the two packages are successfully built. Now again source the setup.bash file. You can use the arrow keys to upward facing arrow key to take back the previously executed command and press enter. Now type the command ROS launch your package name, move it, robot, armsim, and type the command demo underscore gazebo dot launch and press enter. Now when you launch this file here, you will find the issue that parse as old deprecated model file failed. You will face this issue and your model will not load in Gazebo and nothing will proceed further. So this is happening because the launch file generated by Moveit Setup Assistant had some issues. It is not generated correctly. So to solve this issue, we will create our own launch file and we will use that to load our simulation successfully. So please watch my next tutorials in which we will solve all the issues available in this Moveit package that we have generated in this tutorial, and we will load it with our custom launch file. So please stay tuned for the next tutorial. Thank you so much for watching my videos. Please hit the like button and add your comments what you think about my videos. Please add your suggestions if any, and don't forget to subscribe my channel if you haven't yet, and please share it with your friends. Thank you so much.